Here we've got a couple examples to continue on doing the same thing. So this first one, 12 times 1 over e to the power negative x. I'm going to start by separating that negative x out, and that's going to be 12 times 1 over e. I'm going to keep that in parentheses just so I don't get things mixed up. And that's going to be negative times to the power of negative 1 times x, which would be the same as 12 times 1 over e to the negative 1 to the x. And whenever we have a negative 1 power, we flip the fraction over. So that's going to end up becoming 12 times e to the x. And if we think back, e was equal to 2.718, which is greater than 1. So I can say that this function is going to be growth. For this next one, we have 1/3 times 16 to the power of, and it's kind of hard to tell, but it's to the power of 2 plus x minus 2, or x over 2. So it's all one big exponent. So I'm going to start by separating out my exponent. Because I'm adding here, that means that I can rewrite this using our product of powers rule. So 1/3 times 16 squared times 16 to the x over 2. I'm going to rewrite that again with that x over 2. I can split that up. And now I have a power to a power rule that I'm going to be messing with here. So 1/3 times 16 squared times 16 to the 1/2 to the power of x. Now, simplifying all these things out, 16 squared is going to be 256. And then that 16 to the 1/2 would be the square root of 16. So that's going to be 4 to the power of x. That is not a y, that should be the number 4, sorry. And I can simplify that one step further to say I have 256 over 3 times 4 to the power x. 4 is greater than 1, so this one is also growth. Remember, if you have any questions, you can come into office hours today and make sure that you send me an email. We could talk about it in class on Thursday. Whatever works for you. But if you're stuck, if you're confused, please, please, please make sure that you come in. Let's get some help so that we don't fall behind.